Hello. In this lesson, we're going to talk about quadratic function. Quadratic function, I'm sure you have seen it. Okay, so let me type the word. Quadratic function. Quadratic function is actually a family of functions. So we're going to use a plural here. Okay, we're going to use a plural here. Quadratic function has a variety of properties. And it can turn into a variety of different forms after the function composition and adding, subtracting, multiplying, dividing. So how does a quadratic function look like? The general form look like this. Okay, f of x equals to a times x squared plus b times x plus c. And here we would like to have a not equal to 0. This is to guarantee that we're gonna have degree 2, okay, to guarantee. So quadratic function basically is a trinomial that we have learned in polynomial. We definitively have studied this very special cases, right? Cases. Let's look at these cases. The first case, it could be a equals to 1, right? B equals to 0, C equals to 0. Okay. In this case, our quadratic function will become just a equals to 1. B and C are 0, so it's just going to be x squared. We study this function and its domain and range, graph, etc., etc. Okay. Another case is that what if a is negative 1, right? What if a is negative 1? And b and c are 0, right? And in this case, f of x is going to be, the quadratic function is going to be negative x squared. It's going to be negative x squared. Okay. And so as we keep going, we can have all kinds of quadratic equations. Quadratic functions. Okay, this is a quadratic function. We say it is a quadratic function because it is a rule. Okay, the rule says that the input is x, right, and the output is going to be applied, by applying the rule of the function, right, and we get the output, which is f of x. And that f of x is just like that, okay? Provided a, b, c are parameters. A, b, c here are parameters. For example, a, b, c will be given in the special, for each case you're dealing with the quadratic function, they will all have different values for a, b, c. A, B, C can be any real numbers, but of course, A cannot be 0. So that's what we require. Okay, so let's see how are these two functions related, x squared and negative x squared. Okay, so let's observe these two functions. We know x squared for sure. Okay, and how about negative x squared? Right? And these are two different rules. These are two different rules. For example, the former, right? For this rule, okay, so whatever input, we're going to multiply the input by itself, and the output is going to be x squared. Okay, negative x squared. Okay, how does a function of a negative x squared work? Right? And this is how we will have x as input, excuse me, as input. So we get output x squared. And then we change the sign of the output from the previous. It's just one more step. So it's just one more step. So that's the order of operation. So for example, right? If the input is -1, right? If for input equals to -1, for both functions, the output will be different. The output will be as follows. Okay, input a -1, input a -1, and in this case, a -1 squared. Okay, and in here, -1 squared. Okay, but after we get -1 squared, -1 squared is -1 times -1. And equals to +1. Okay, but then if we get +1 here, we put a negative sign. So this piece, the last piece, okay, is going to be something like that. Okay, we put a negative sign. So since this is 1, so the outcome, the output will be -1 for the first function, -1 for the second function. Okay, for this reason, right? We and in the case of say, for example, some people ask the question, what's the difference between -2 squared, right? And the other one is -2 squared like that. What's the difference between these two? Right? Are they the same? Right? Are these two the same? Are they the same? Well, you have to look at the order of operation. Okay. In the first one, okay, for -2 squared is that you have -2 and you follow the rule of the function, you get a -2 squared. -2 squared is -2 times -2. It equals to 4. So the input is -2, the output is 4. The second one actually is not the same rule of function. Is the input is 2. So 2 squared is 4. And then we put a negative sign in front of 2 squared. So we get a -4. You see, they're totally different rule of the function. Okay. For that reason, we need to make sure to understand that these two are completely different. Okay, they are completely different. Okay, that is like -2 squared, where -2 is in the parentheses, and the other one is -2 squared without the parentheses, and that these two are completely different. And there are numerous similar examples. Just be careful, okay? The order of operation is implied. Okay, so these are the examples. So next, we're going to look at the graph of these two functions. Okay, we're going to look at the graph of these two functions. Okay. So we're going to graph these two functions. For x squared, we already know, right? X squared, we already know. X squared, we certainly have done it. Okay, that's the output. Input is x. So input output, right? Input output, right? So we get pairs of numbers. So for input, we can choose -2, -1, 0, 1. And I'm going to add one more row. Okay, 2. For -x squared, however, right, that's different rule. So we should have a different function. So there's a negative. And we still use the same input. Because we're still going to use the same input. Okay, so for the same input, let's see what we get for the outputs, right? So for -2, we're gonna get -2 squared. Okay, and this one is gonna be -1 squared, 0 squared, and here is 1 squared, and 2 squared. Done this before, so let's get this done quickly, right? So that's going to be 4. That's going to be 1, 0, 1, 4. And the points, you can see whether the input is negative or positive, the output are always a positive or 0, right? So if the input is 0, the output is 0. So for this function, right, regardless the sign of the input, the output is always non-negative. Non-negative, when I talk about this is the range of x squared, okay? The range of x squared. And so the point is -2, 4, whoops. Okay, so this is a -2, 4, wait, 4, right? And this is this next point, input output is -1, 1, 0, 0, right? 1, 1, and 2, 4. Okay, for the other function, however, right, for the same input, right? So our output is going to be replacing x by -2. So x is replaced by -2, right? And this will equals to negative, right? So we know this piece is 4, right? We have done it. So this is going to be -4. So for the same input, -2, and the output here is going to be -4 under this rule of the function. Okay, and next we'll do one by one. -1 squared. Okay, be very careful, write the way exactly as I do here, please. Okay, input a -1, output a -1. For 0, no difference. Okay, it's still 0. Okay, so x is replaced by 0, so that's going to be 0. 0 is not positive and it's not a negative either. It's a neutral number. It's a neutral number. And the next one is you're going to have -1 squared. And that's going to be -1. And the output is going to be 1 input, output a -1. For 2 as input under this rule is -2 squared. So that's going to be equals to -4. And the output is -4 when the input is 2. Right? So let us plot the point. Let us plot the points. Okay. So I'm going to set up the rectangular system. Once we understand the inner working of one function, we will see that a similar situation will also work for other functions. So this is the reason we do what we do. Okay, this is the reason what we do. Because we get to see, okay, we get to see how it works, right? You can see the basic action are very, very similar, very, very similar. So this point, I'm going to put the rectangular system right in between so we can put the points in the graph and in comparison, okay? So suppose we put the points for x squared. We have done that before, so this should be a breeze, okay? So that should be very easy. I'm going to choose a color for x squared, right? So we have input a -2, output 4. And we're gonna choose the black dot. Right, the next one, input a -1, output 1, and input a 0, output 0, input 1, output 1, input 2, output 4. There you go. These are the points for x squared. These are the points for x squared. For negative x squared, right? So we got these points. So we're going to use a different color. We're going to use a different color. Let's see, what color would you like? Okay, so let's do the color of, let's do -2, -4, right? Let's just use red, right? Red dot. The second point, we're going to put in -1, -1. And 0, 0 is one of the points too. The next one is 1, -1, 2, -4. You see the picture, just the sign of change, right? Just the sign of change. Just put a negative sign in front of the other function, the other rule function, right? The entire picture flipped over. Okay, so if we connect the dots, okay, if we connect the dots, we have x squared, right? That's the black, and the next one is -x squared, and that's going to be the red. If you look at this table, right, the change of sign on the output of x squared caused the entire picture of x squared flipped over the point, the lowest point of that parabola. These are called one parabola, the other one is called the other parabola. Okay, and this effect is not unique to quadratic. This effect is not unique to quadratic. Okay, so I'm going to show you how this phenomena is not unique. For example, this is x squared, and this is a -x squared, right? So I'm going to show you an example, which is, let me write down the function, okay? The function I'm going to show you, one is e to the power x, right? And the other one is -e to the power x. So you put the output, this is the function, and you put a negative sign on the entire function, right? So let's see, what is e to the power x? This is e to the power x, right there. Okay, what is -e to the power x? -e to the power x. Red, flip over. Okay, so you can see this phenomena is not unique to x squared. Let's look at another example. Okay, the other example, which one do you want to see? How about natural log x, right? ln x, right? A negative ln x. Let's see what we get. Okay, ln x and negative ln x, right? So I'm going to take this picture, okay, just change the function. The function will be changed to ln x, right? So this is going to be ln x. Hold on, wait. ln x, okay? And wait. Where's my negative ln x? Is that negative sign there? There's a negative sign there, yes. There. You can see that curve, right? Flipped over, flipped over. So this phenomenon, in fact, let me show you a bit more on the picture. Okay, this black one is ln x, negative ln x. The negative flipped up, positive flipped down. Okay, so this phenomena is not unique just to x squared or negative x squared. So those phenomena is very, very common. So let's look at another function. How about sine x, sine x, negative sine x, right? Sine x, negative sine x. Let's look at that. Sine x. Sine x, right? We got it. Okay, so let me make some adjustments. So you can play with it. You can play with it. You can play with it. Here we go. Sine x and negative sine x, right? So we got sine x. We haven't done the negative sine x yet. Okay. So this phenomena is not unique. Okay, so I'm going to plot negative sine x, and this is going to be red. Before I plot it, what do you expect negative sine x will be? Opposite, right? The output will be the opposite for sine x, right? So the negative piece is going to flip up. The positive piece is going to flip down. The crossing at 0 stay the same. Okay, so let's see if that's true. Boom. Okay, so this is the effect. This is the effect. Okay, this is the effect of f of x and the negative f of x. Okay, you can try cosine, tangent, any function, and maybe even more complicated than these functions we're doing. You can see the picture of a negative f of x is just the f of x flip over piece by piece over the x-axis. Negative flip up, positive flip down, and the crossings with x-axis stay the same. Okay, so that's one interesting phenomena, isn't it? Okay, so now let's go back to this case. Let's go back to this case, right? So a lot of the properties we study for one function, you may want to think, oh, will that work for other functions too? Okay, will that work for other functions? Okay, so continue from here. Continue from here. The next few functions I like to consider is actually, you know, from our cases, right? From our cases. What if, right? What if? Okay, so I'm going to give you the case. What if, okay, a is 2? What if a is 2? And this is going to be 2 times x, right? 2 times x squared. What if this a is half? And this piece is going to be half x squared. What will be the effect on picture? What do we see? Right? So if we graph the function 2x squared, half x squared, in comparison with x squared, what do we see? Okay, so I'm going to take this piece of the picture. Okay, so I'm going to drop the negative piece. I'm going to drop the negative part, just look at the positive part. Okay, because we know if we put negative sign, you just flip over, so we don't need to do that again, right? So we're just going to have that. So this is x squared. This is x squared, okay? And I'm going to make that dot red. Just make that black dot. Okay, so this is x squared. What would we like to see? What will be 2x squared? Will be half. What will be half x squared, right? So how does it look like? How does it look like? Okay, so we have the table for x squared, right? We have the table for x squared. Now we're going to keep that table. Okay, we keep that table, right? And we're going to add to the table, right? For the same input, okay? What would be 2 times x squared, right? What will be 2 times x squared, right? That's a 2x squared, right? So we're going to set up another column. Oh, wait, what did I do? Okay, I'm going to insert another column here to do the 2x squared, right? So we got an x squared. So we're going to put a 2x squared. Oops. So this is going to be 2x squared, right? We know what x squared is. So 2x squared, it would just be doubling the x squared, right? You'd be just doubling the x squared. Okay. Or we can, for convenience, let's do this. We put 2x squared up out here, right? And we're going to put a half x squared. Okay, half x squared. Half x squared obviously is whatever we get for x squared, we're going to half of it, right? So there's a column of points for 2x squared, and there's a column of point for half x squared. 1/2, right? So input, output, input, output, input, output, right? So if x squared is 4, 2x squared is what? It's 8. So the output is doubled. Okay, 2 times x squared. So twice, 2 times 1, that's 2. 2 times 0, that's 0, right? So 2 times 1, that's going to be 2. 2 times 4, that's going to be 8. Okay, how about half? X squared is halved, right? X squared is halved. So this output will be what? What happened to this output? Well, 4 will be halved, right? So that's going to be 2. And 2 will be halved. 1 is halved, it's going to be half. Okay. 0 is halved, is still 0. 1 is halved, is half. 4 is half, that's 2. So we got the point for 2x squared, same input, right? So all of these are going to be the same, but the output is doubled. The output is doubled. So the output is doubled. Doubled, stay the same, 2, and this is 8. Okay, so the output, you see, the input stay the same, the output is doubled. Okay, I want you to put that in your mind. And the next one is the input stay the same, the output is halved. Okay, the half of 4 is 2, half of 1 is half, right? Half of 0 is 0, half of 1 is half of 4 is 2. So now we're ready to plot points, okay? So we're gonna choose, maybe we'll make it obvious of the colors, right? This color is what? It's black. Okay, and we're gonna choose the color for 2 times x squared, right? You can see the input stay the same, the output is doubled. Okay, so we're gonna plot these points. Okay, we're gonna plot these points. And what color do we want? Maybe green, why not, right? Point. And for -1, the output is 2, the output is 1, and then doubled is 2, right? And another point, which is 0, 0, 0, 0 overlapped, right? And 1, this is 2. okay? And that's 2, 8, 2, 8. So these are the dots, okay? These are dots. You can see there's some dots not showing up, right? We have 5 points. So this one doesn't show up because I need to make some adjustment to the picture. So these are the green dots. Okay, the green dots are for 2 times x squared. So this color is going to be green. Green. 2x squared actually is, you see, every output, input stay the same, output is doubled, right? Output is doubled. You look at that visual, right? For input 2, right? For input 2, the output is what? For input 2 on x squared, the output is 4. 2x squared is doubling this height. That's double. That's the effect of doubling. Okay, doubling on the output. So vertically is twice as long. Okay, if it's a negative, it will be twice as long in the other direction. Okay, so now I hope this helps us to see the visual. So let's do the 2x squared picture, connecting the dots. I'm gonna still using the green. Boom. So the green, right? You can see the green is thinner, or closer, or narrower than x squared. So this is narrower. This is narrower. But in terms of domain and range, actually the domain and range are the same. Domain and range are the same. Okay. So they have the same range. And next, look at half. Look at half, right? So all of these points. So now you can imagine, you can also almost imagine what happened to the half, right? The black, this height for 2 on x squared will be halved, right? So let's plot the dots. Let's put the dots in place, right? So we're gonna put the dots, say -2, 2. Okay, so -2, 2. Let's see what color do we want. How about we use purple, right? And for input -1, the output is half, right? It's halved. And 0, 0 stay the same. So that's the same. And for 1, the output is half. Okay. For 2, the output is 2. Look at that. You see the output for the same input, the output is halved. So if we connect the purple dots, okay, so we got half x squared. Okay, we got half x squared. And the purple there. Okay, so this is our purple. So what do we see? What do we see? When we double on the output, right? The graph will be narrower. If we halve the output, the graph will be wider. So that's pretty obvious, right? So this will give us a very good reference. What if I put a negative sign in front of all of these? Well, everything will flip over, right? If I put a negative sign, if I do negative x squared, negative 2x squared, negative half x squared, what will happen? Well, all these curves will flip over. So the negative sign, the negative of f of x, we did it, right? So double, right? So 2 times, so let's summarize, right? if we do 2 times f of x, right? What's going on? We are doubling the output. We're doubling the output, okay? It's narrower, it's more narrow, okay? More narrow. How about half of f of x? Okay, the output is halved, it's wider. Okay, wider. Wider. Okay. Is this true for every curve? The answer is yes. The answer is yes. Okay, you can try them. You can play with them like what we did before. Okay, so this is about the effect. Then you say, well, what if I do 3 times f of x? Same idea. Okay, 3 times is going to even more narrow. Okay, would it be 1/3 of f of x? 1/5 is 1 of x, right? And it will be wider, right? And in comparison, you know, basically the number you multiply, if it's less than 1 in absolute value, it's going to be wider, right? Then you say, why do you see absolute value? Why do you say absolute value? Okay, let's take an example. If I have a negative 1/2 x squared, what do you think you're going to get? What do you think you're going to get? So if you take that picture, we know the purple is 1/2 x squared, right? If we have a negative 1/2 x squared, what will happen? I need to make adjustment to the view. What will happen? Negative 1/2 x squared. Have you guessed it? Have you guessed it? Okay, the purple one. Okay, the purple one. I'm going to turn that into a light blue, whatever. Have you guessed it? All right. The purple flipped over. The purple flipped over. The red one was a negative x squared, okay, which is the opposite of x squared. Okay, so you can see the blue, this light blue is the negative 1/2 x squared. It flipped over, right? So it works that way. The next thing we're going to do is that we're going to observe the functions shifting. Okay, horizontal shift and vertical shift. Horizontal shift and vertical shift. Okay, so let's look at a couple of functions. So let's look at a vertical shift. Vertical shift. Okay, vertical shift as a function, right? If we look at the cases, right, of the general form, right? Let's look at some vertical shift. Suppose I have A equals to 1, B equals to 0, C equals to 1. What function would that be? A is 1, right? B is 0, so this term is gone. C is 1, x squared plus 1. And what if I have another 3 numbers, but this time C is a -1. And as a result, this quadratic function will become x squared minus 1. So in this case, how does the picture look like? How does the picture look like? Well, we first have to understand the order of operation. Okay, so we basically do x squared. And after we're done with x squared, what do? we add to the outcome of x squared by 1. And in this case, we subtract from the outcome out the output by 1. So 1 is adding 1, 1 is subtracting 1. Okay, so now let's see from the algebraic operation. Okay, from the algebraic operation, what do we get? So I'm going to take these two. I'm going to put it here. I'm going to remove the red. I'm going to remove the red dot, okay, because we already got that piece. Okay, so let's see, what are the red? I'm going to just delete. Is that clear? One more. X squared, negative x squared must need to be deleted. And here we go, it's clean, right? And so the view is pretty good. And we're gonna work on the x squared plus 1, x squared minus 1. Okay, x squared plus 1, x squared minus 1. So what are we gonna do is that I'm going to do I'm gonna add 2 columns. Okay, one column will be x squared plus 1. And the next column will be x squared minus 1. And so the other 2 columns I'm adding 2. Okay, it will be the input output, right? So input, output, the input is x, output is plus 1. And the next one is going to be output minus 1, right? So we're going to have 3 curves, 1, 2, 3. Input the same, output x squared plus 1, x squared minus 1. Okay, for our comparison. Now, we got x squared, right? Input x squared plus 1. What will happen? 4 plus 1, right? So that's 5. And that's going to be what? For input and -1, the output is 1, and 1 plus 1, that's going to be 2. 0, right? Input 0, output 0, and that 0 squared plus 1, so this is going to be 1. So this is going to be 2, and this is going to be 5. Okay, subtract 1, right? 4 subtract 1. So for input and -2, for this function, it's going to be 3 because of 4 minus 3, and there's a 1 minus 1, that's going to be 0, right? 0 minus 1, that's going to be -1. And 1 minus 1, that's 0. 2 minus 1, 4 minus 1, that's going to be a 3. We got our points, right? We got our points. So on this, x squared plus 1, the input stay the same. The output will all add 1, right? Because x squared plus 1. So this is going to be 5. This is 2. And this is 1, this is 2, and this is 5. Does that make sense? Okay. And the next one, subtract 1, right? X squared subtract 1. So this is 3. 1 minus 0 is 1 minus 1 is 0. So this is going to be -1. And that's going to be 0. And that's going to be 3. Right? So the f for x squared plus 1 curve, we got these points, right? Input stay the same. The output is what? The output all added 1. 4 plus 1, 1 plus 1, 0 plus 1, 1 plus 1, 4 plus 1, right? So what do you imagine before we plot the points? What do you vision? Okay, so let's put the points in place. Okay, let's put the points in place. Okay. So we're going to put those points and we choose a color and see for ourselves. Okay, so for -2 now is 5. And I'm going to choose a color. This color, let's just do green, right? Just 3 colors. -1, 2. -1, 2. Okay. 0, 1, 0, 1. Oops. 1, 2. Okay, 2, 5. 2, 5. So we have these dots. What happened? What happened for x squared plus 1? Input stayed the same, right? Same input, but the output is shifted up vertically by 1 point. You see? That's the effect of x squared plus 1. That's the effect. Every point is shifted up from x squared to reach x squared plus 1. Okay, so if we connect the dots, right, the green dots, here we go. That's shifted up. So now you guessed it. -1, x squared minus 1 is going to be shifting down by 1 unit. It's going to be shifting down by 1 unit. So let's see. I'm going to put those points in place. You guessed it, right? So now we just need to take our time to put the points in the picture. Okay. So just be patient with yourself just to experience this. Okay, experience this. We're going to use what value, what color, right? How about this blue, right? Is that striking enough? Okay. The next point is -1, 0. And the next one is 0, -1, 1, 0. Oops. 2, 3. Okay, we got a bunch of blue dots. Let's see. Look at those blue dots. Look at those blue dots, right? Blue dots is a consequence of shifting x squared. Okay, we have a -1, so subtract by 1. Subtract 1, so shift it down vertically. Shift it down vertically. Okay, and this is for every point. This is, of course, for every point. Okay, so now we connect the blue dots. X squared -1. And we choose blue. And here we go. So that's the shifting. That's the shifting. Okay, so that's the vertical shift. That's the vertical shift. Okay. So what have we seen? What do we see here? What do we see here? What do we see here? Right? If you see the function, right? If you say here, the black is the function, right? If you take the entire function, you +1, the entire curve will shift up. If you take the entire function -1, it shifts down. So for +2, -3, +5, -7, same idea. It will be the same idea. Will the same idea work for other functions? What do you think? What do you think? Will the same thing work for other functions? Will it work for, say, absolute value of x? Okay. Does it work for absolute value of x? Okay, hold on. Where's my absolute value? Where did it go? Okay, here. Okay. Right? If you look at this piece, right? You have absolute value of x plus 1, right? And the absolute value of x minus 1. What do you think? What do you think the picture will look like? You may like to pause the lesson and try yourself. So if you understand one situation, you'll probably understand many situations, right? So the absolute value of x, so if I draw a picture like that, right? So this is going to be the picture of absolute value of x. There. Okay, absolute value of x. But what will be x, absolute value of x plus 1? Right? What will be absolute value of x plus 1? Well, let's graph it. Absolute value of x plus 1. And we're going to use what color? Green. Why not? Green. Shift it up. You see, shift it up, right? Absolute value of x minus 1. Okay. Shift it down. Shift it down. Every point is shifted up in this case by 1 unit. If y plus 2, it will be shifted up by 2 units, right? In this case, every point is shifted down from absolute value of x down by 1 unit. So, and if you subtract 5, you're going to be shifted down by 5 units. Does that make sense? And then you would say, oh, will this work for other functions we have seen, right? Does it work for e to the power of x? Does it work for e to the power x, right? E to the power x, e to the power x plus 1, right? The entire function plus 1, e to the power x minus 1. Let's see what happens. Let's see what happens, right? That interesting? Okay. Do you think it's the same thing will happen? Do you think the same thing will happen? Okay. You may like to pause the recording and, just work out something on your paper, paper with your pencil and see for yourself, right? So here I'm going to do this picture, right? And let's see, I'm going to put here, it's just 3, okay? So that's e to the power x, okay? E to the power x. For e to the power x, if I do e to the power x plus 1, right, the entire function plus 1, what will happen? It's the entire function will shift up. The entire function shift up. Every point shift up. Okay, every point shift up. Okay, every point shift up. And how about e to the power x minus 1? And this is going to be the blue. You guessed it. Shift it down by 1 unit. Shift it down by 1 unit. Will this work for sine, cosine, tangent, cotangent? Of course, of course. Let's take a look at cosine x, right? Cosine x. Excuse me. Okay, so let's look at cosine x. Okay. So what do we want to see about cosine x? Right? Cosine x plus 1, right? Cosine x minus 1. The entire function, right? Adding 1, subtracting 1, right? We understand how it works, right? You first do the function, you get an output, and that output plus 1, that output minus 1, right? So let's first graph cosine x. Boom. Right? In modern time, the graph is at our fingertips. Okay, cosine x. This is a cosine x. what happened to cosine x plus 1? The entire curve is lifted up by 1 unit. Okay, so let's see if that's true. Do you visualize that? Do you see it? Are you ready? Boom. Every point is shifted up by 1 unit. And of course, you can see it works every single time. It works every single time. Okay, shifted down by 1 unit. Okay, shifted up, shifted down, right? So the entire function, right? So in this case, if you have a function, right? The entire function, it doesn't matter which function, right? It could be very complicated. The entire function plus 1, so the output plus 1, and or the entire function minus 1, right? That's a vertical shift, okay? These are vertical shift, okay? So this, I'm going to use this picture to illustrate, right? So this is f of x, right? And the green, you know what, I should use the wrong, I use the right color. I should use the right color coordination, okay? So this is going to be f of x, okay? In our case, this is a cosine. And the green is f of x plus 1, the output plus 1, okay? The blue is f of x, the output minus 1, the output minus, right? And we have, so it's time to do a little summary, isn't it? Because the next one, we're going to do another kind of shift. So before we do another kind of shift, let's summarize. Okay, let's summarize. Okay, so we have this case, right? We have this case. What else cases do we have? Shifting up and down, right? Shifting up and down. What else have we done? You know, narrower, wider, right? And the other case we've done is flip over, right? So we have this case. Okay, we use some examples. Okay, so that case, right? And this case, no, I'm going to just use this case, but we try to keep it simple, okay? We try to keep it simple. And the next one is this kind of shifting. Okay, vertical shift. So we have discussed these 3 cases with much examples, right? So we can see those examples. In this case, right, this is f of x, and flip over is a negative f of x. And we see this happens to many situations, including sine, right? Sine and e to the power x and so on and so forth. And for these, right, for these is that we have, this is f of x, right? And this is a 2 times f of x. And this purple, right, is half of f of x. Okay, once you have plotted these pictures, right, you understand what's going on, what's the order of operation, and what's the consequence after plotting those points. You'll be so clear about these concepts, these, you know, the expression, okay, make sure you write it down properly, Okay. And last but not least, for what we have done so far before we move forward. Okay. In this case, that's the vertical shift. So this is f of x, right? And moving up, we have here is f of x plus 1. Sometimes we say plus 1 outside, right? But I want to emphasize the plus 1 is on the output. Excuse me. And this minus 1 on the output. We emphasize it's on the output. On the output. Okay. You can see all of these operations we have done, right? All of these operations we have done. This one is on the entire output. We'll put negative sign in front of the entire function, right? So in this case, that's this is f of x, right? And you put a negative sign in front of the entire function. In front of the entire function. So these two, right? And in the next case, right? In the next case, you know what? I should make a table. So that way it's going to be very easy to move around, right? So I'm going to make it move around. Let's do a little table here. One more column, just in case, right? So f of x, negative f of x, right? So that picture is flipping over, right? That example, and we can even put more examples here, right? And the next case is over here. Let me delete it. Okay, so put over here. That's gonna be the second column, right? So what are they? What are they? Right? So we have the, so let's make the color tone. Let's do this first, right? So we have x squared, right? And we have 2x squared half x squared. In this case, okay? It can be inferred for f of x, right? It can be inferred for f of x, right? 2 times f of x, right? Half of f of x. No, those are the inference, right? Those are the inference. In this case is, of course, x squared, right? Negative x squared, which is inferring to f of x negative f of x, right? The last one, I think this picture is a little too, oh, we can make it thinner. Yes, we can make it thinner. So we can use this one, or let's do the other one. Didn't we? Yeah, let's use this one. Then we add other examples. Okay, so we want to make it a more comprehensive summary. I don't think we need the last column. Okay, so this is the case that we have x squared, right? X squared plus 1, x squared minus 1. Okay, which refers to f of x, right? F of x plus 1, f of x minus 1. Okay, so let's just put them that way. Oops, right? We put them that way. put them that way. Okay, and we certainly did more examples than these, right? So this is the example for, trig function cosine. And they are all color coordinated, right? We have their color coordinated. So all of these are examples, right? And for this case, and we didn't make more examples, you certainly can make it up. You certainly can make it up. And for that one, we did a lot of flipping. Oh, and e to the power x, those are also the examples, right? I think that's enough, right? That's enough, that's an e, right? And for cosine, for the sine, for the flipping over, we really did some very interesting examples, didn't we? Right, ln x, negative ln x, right? So this is a good, very good example. Okay, so I'm going to bring that over. I like that example. Okay, these examples are going to be very useful for you. Okay, they are going to be very useful for you. Okay. E to the power x, right? So that example, okay. And we did a sine, right? I think the sine example is also very nice. Okay. We're not going to put everything in the table, okay? And for the middle part, and you can just you can just work out some examples yourself. Okay. And over here, so these are about the shifting, right? This is about negative f of x, negative f of x, and 2 times half, and vertical shifts, vertical shift. So now we've done all of these. Are we ready for more? Are we ready for more? Of course, I think you are. I think you are. For next, we're going to do another kind of shift, right? If you look at these pictures, if you look at these examples, right? These are vertical shift because we finished the input-output process for f of x, and on the final output, we add 1 or subtract 1. So the consequence is either shifting up or shifting down. These are vertical shift. These are vertical shift. But what if we add 1 or subtract 1 on the input? Okay, so instead of doing these, okay, be careful. These things often confuses a lot of our students. I certainly don't want to confuse you. Okay, I don't want to confuse you. These are vertical shift. We have seen it, vertical shifts, right? F of x, the entire function, right? The entire function. So x, where is it? Oh, never mind. Vertical shift. So that's the vertical shift. We just discussed those vertical shift, right? So f of x, take the input, right? Take the input and f, and then we get f of x, right? And after we get f of x, we take f of x, we plus 1. Okay, that's f of x plus 1. So that's the flow. For f of x minus 1, the flow is similar, except that in the end, we subtract 1 from the output. Okay, so these are the vertical shift. These are vertical shift. Okay, so these are the vertical shift. But how about the adding 1, subtracting 1 is on the input? In other words, what if, okay, look at this example, okay? Suppose I have a function f of x, it's equals to x squared, okay? So I'm going to do a new function. On the input, I'm going to add 1. So I got x plus 1 squared, okay? On the input, I subtract 1. Then I got x minus 1 squared. You see the difference, don't you? Right? What is the flow here? The flow here is that we choose our input, okay? And input plus 1 before the function is applied to the input. So as a result, this is going to get us f of x plus 1. So that you can see that process is very different, right? It's very different. For f of x minus 1, okay, so that flow is that before the rule of the function apply to the input, we do subtract 1 from the input. And then we apply the function, the rule of the function. And we got f of x minus 1. Okay, you compare these two processes. They're very different, aren't they? They're very different. Okay, in the former case, right, in the case of f of x equals to x squared, so we got x squared plus 1, right? So you look at the examples, right? Examples is x squared plus 1, right? You first square and then you do plus 1. And the other example is that you finish the rule of the function and then you subtract 1, right? We've done those. But these cases under these examples, it's actually you add the input by 1 and then you square it. Then you square it. What would happen then? What would happen then? Okay. So for this reason, we're going to study these three functions. These three functions. Okay, we already studied x squared, so we're going to just borrow that. Okay, we're going to just borrow that. Hold on, I'm going to take this table. Okay, I'm going to take that table. But this time, we're going to have to, we're not going to change the input. We're not going to keep the same input. We're going to do different inputs, but to get the same output. Okay, so let me show you. Okay, let me show you. So this is x squared, right? So the next table I'm going to do is going to be for, I'm going to make another table. Okay, 1, 2, 3, 6 row, 2 columns. There. Okay, and of course we actually should have 3 columns, right? Input, output, right? So yeah, let's make 3 columns. Okay, input, output. And for this function, my function is going to be x plus 1 squared. Input, I'm going to make choices. I'm going to select inputs. Okay. And the next one, you guessed it, we're going to do x minus 1 squared. So we're going to select our input. Okay. So we have input, output, right? So this is the input, output. And this is input, output, right? So this is another way of showing input, output, right? And over here, and of course, we also have input output. This is a -1. Okay, so how am I going to choose the points then? How am I going to choose the point? Right? And this is how I'm going to choose the point. Okay, the first input, I'm going to choose -3. Okay, so here I will be having -3 plus 1 squared, right? And so that's going to end up to be -2 squared. I want to show you how to do this, right? So I get a 4. And the next point, I'm going to choose, of course, -2, and this is going to be -1, and this is going to be 0, and that's going to be 1. What I matched the output. Okay, so let me, this way we save a little space, okay? So for the next one, when I choose input equals -2, the output is going to be -2 plus 1, and the output is going to be 1. The next one, right? The next one, the input is going to be -1. -1 plus 1 is 0. 0 squared is 0. And the next one, right? Input is 0. And 0 plus 1 is going to be 1. 1 squared is 1. Next, 1 plus 1, and that's going to be 2 squared is 4. So the points I have here, okay, if you look at the points I have selected, right? Of course, this is intentional. Right? Input a -2, output is 4 for x squared. Here is -3, -3 output. So for a different input, the output is the same. Okay, and then for -2, the output is 1, but for 1, the output is 1. Right? We are familiar with x squared's value, 0, 0, and 1, 1. Then you say, why do you choose it that way? Well, to make a point, okay, to illustrate. Could I just still choose, the same input? Of course you can. Okay, you can. You're gonna get the same curve for sure. But this way of choice, it makes us see better and sooner, faster. Okay, so the next point on x plus 1 squared, so this is going to be input a -1, output 0, right? And this is input 0, output 1. Wait, 1. And input 1, output 4. Okay, so are we going to come back to do x minus 1 squared to see what do we get for these two? Okay, do we have to, well, I think we have a picture of x squared already, right? So we don't need to do that over, right? So we don't need to do it all over again. So we just use this one. And I'm going to remove the red. Okay, I remove the red. And now I'm going to put the points for x plus 1 squared on the graph. Okay, so I'm adding -3, 4, right? So what color do I want to choose? Green, right? And what is the next point? What is the next point? That's going to be -2, 1, right? And -1, 0. Well, you probably can go back to look at that. So this one is going to be 0, 1. 1, 4. Right? Okay. I think. Oh, my bad. I forgot to change them to points. Okay. The green point, the green point, the green point, the green point. I think we got them all. We got them all right there. Okay. What happened? Let me put this picture in between. Okay, we'll put this picture in between. For the same output 4, right? For the same output 4. Okay, the same level 4. On the x squared, it can be achieved at a -2 and +2. But on x plus 1 squared, it will be achieved at a -3 and 1. So at -3, we get a 4. At a 1, we get 4. So if we connect the green dots, okay, so x plus 1 squared. Okay, the green color, what happened? The entire curve of x squared is shifted to the left, by 1 unit. Shifted to the left, shifted to the left, shifted to the left. Okay, shifted to the left by 1 unit. Now, your educated guess. What if we do x minus 1 squared? What do we do x minus 1 squared? Think about it, right? How would you choose those points? How would you choose those points? Right? So if you like to pause the lecture and do your own thing, great. Okay, why not? Right? So I'm going to take this table next to each other, right? So we're going to use the same. So you can see this way of choosing points is much, you see it much quicker. But if you don't, you can still see the same phenomena for sure. It's just you have to choose more points. You have to choose more points. Okay. But anyway, so for here, how would you choose our points? Well, I'm going to choose a -1. Okay. Because -1 minus 1 is going to be -2. -2 squared is 4, right? So -1, 4. So you probably understand the mechanism already. So the rest is just practice and enhance your skill algebraically. Okay. So for 0, the output is 1. And the next point you choose is 1, 2, 3, of course, right? So each one you're going to put in your point, and this is going to be 0. So 0, 0. So once you do this one time, really, or well, for maybe 3 times, you want to really get really good. These process will leave lasting, impact on your understanding. Okay, on your understanding. So this one is 3 minus 1 squared. That's going to be 4. And that's going to be 3, 4. Right. So you already guessed the picture. We actually already guessed the picture, didn't we? So I'm going to take this picture and put more pictures in place. Right. So I'm going to put this over here. Right. I'm going to put the points in place. Okay. And I'm going to add this dot. This is going to be blue. right? Another point, 0, 1. Actually, I can see that we can see the point right here, right? So 0, 1 and 0, 0. Wait, 1, 0, sorry. 1, 0, my bad. 1, 0, okay. I made a mistake here. So this is a 1, 0, my bad. It cannot be like that. Okay, 1, 0, 2, 1, 3, 4. Okay. So 2, 1, 3, 4. Oh, wait. Also, what did I do? Oh, my bad. What did I do? Okay, I have to do it over, right? So 1, 0. Where's 1, 0? Oh, yes, there you go. 1, 0, 0, 1. There's a need a dot. That's why. Negative 1, 4, and add one more point. 2, 1. Sorry about that. 2, 1, 3, 4. Okay, there we go. All the points, you can see all the points on the black is shifted to the right by 1 unit. So if I collect the red, the blue dots, if I collect the blue dots, right, connect the blue dots, that's going to be x minus 1 squared. The blue curve, ta-da, there you go. Okay, so now you can see if we do x plus 1, it's going to be shifted to the left by 1 unit. If we do x plus 2, it's going to be shifted to the left by 2 units, right? If we do x minus 1, it's going to be shifted to the right by 1 unit. If I do x minus 6, it's going to be shifting to the right by 6 units. Okay, so this is the horizontal shift. You can see the horizontal shift is adding constant to the input instead of the output, like we have explained at the beginning, this shifting. Okay, so let's summarize. Right? So on this piece, right, what do we got here? What do we got here? Right, we're gonna mark it. We're gonna mark it, right? The horizontal shift. Horizontal shift. And this is x squared. Whoops. Black color. Let me try the color coordination, right? So this is x squared. And the green, okay, that's x plus 1 squared. And the blue, that's the x minus 1 squared. We haven't discussed the domain and range yet, haven't we? We have not. So let's study the domain and range, right? The domain and range we're going to study is about these 4 functions. Okay, actually 5 functions in comparison. Okay, so which 5 functions I'm talking about? Okay, these are the 5 functions I'm going to talk about. Okay, 5 functions, 2 columns. So we're going to have, we don't need so many rows, right? How many columns? 5 columns, 5 functions, right? So these 5 functions I refer to is x squared, right? X plus 1 squared, x minus 1 squared, right? And you guessed it, x squared plus 1 and x squared minus 1. What about their domain and range? That's the question. Okay, when you insert a column. Okay, domain and range. Okay, domain and range. Domain and range. For x squared, we know the domain is all real numbers. Okay, negative infinity to positive infinity. And for all of these, the same, right? Domain is the same. No difference. They can be any real number. No question. It's the range that's a little interesting, isn't it? We know x squared is at least 0. What will be the range for x plus 1 squared? Well, that range is also at least 0, right? You already see the picture. They're all, because you square, you add number to the input and then you square. So the consequence is that all of these are going to be at least 0, right? So the picture tells us, right? And x minus 1 squared is going to be what? At least 0. How about the domain? How about the range for these two? Right? I'm going to bring the picture over. So you tell me, what do you think? Okay. What do you think? What will be the domain and range? For x squared plus 1. The green is x squared plus 1, right? You can see the lowest point is 1. So x squared is greater than equals to 0. And x squared plus 1, wait. No, okay. So x squared plus 1 is going to be at least 1. Okay. And for x squared minus 1, the range is going to be at least negative 1. So that's a domain range. You can see there are variations, right? And these variations are no surprises to us because we see the pictures here, right? You see the green, which is x squared plus 1. The lowest point is 1, so it's at least 1. And the blue is the lowest point is negative 1 here, so the rest above it, so it's at least negative 1. For all of these, they're just at least 0 because the square of anything is at least 0. Okay, and if you like, you can put those pictures in place. And I think we don't really need this row. Having them in this form is much easier to understand. Okay, so I think this lesson has coming to an end, almost. Okay, almost. So we've talked about all these shifting, right? Vertical shifting, horizontal shifting. And how can we combine them all? How can we combine them all? Can we combine them all? Yes, we can. We can, right? Because now we know the situation, right? For example number 1. Okay, I'm going to create a new function. And this function, I will have x minus 2 squared. Okay, and then I'm going to time 2. And outside, I'm going to subtract 1. And this is my function. Okay, how does it work? How does it work? Well, we don't have to plot points, right? Because we know that x squared to x minus 2 squared is just shifting to the right by 2 units. So we're going to start from x squared. Okay, we're going to start from x squared right there. Okay, so this is our x squared. Okay, I'm going to make some adjustment for that picture. And the view. So this is negative 3 is fine. Okay, and this is going to be 7, -3. We can always make adjustment about these. Okay, so we got x squared, right? So this is x squared. Maybe I would do a table, right? Let's do a table. Oh. Reduce number of rows. Okay, so this is my x squared. And that's my x squared. Okay, here we go. After x squared, from x squared, we can get x minus 2 squared. Right, x minus 2 squared is just a shifting of x squared to the right by 2 units, right? So that shifting is going to be shown on the picture, x minus 2 squared, shifting to the right by 2 units. We're going to use the green. Shifted to x minus 2 squared. That's the green. And then I'm going to multiply by 2. What will happen if I multiply by 2? Is it wider or more narrow? And next, I'm going to do 2 times x minus 2 squared. Okay, so let me make these pictures just a little, take a little less space, right? So now I'm going to multiply by 2. Okay, by 2, what do you think? Is it going to be, is it going to make it wider or more narrow? That's right, it's going to be more narrow, right? So this time I'm going to make it blue, right? So you can see the blue is more narrow. It's more narrow, right? So I'm going to tell my reader. Because very quickly we're going to be confused about which is which, right? And this color is green. Okay. And the next one is blue. And what's next? Right? These part is done, subtract 1. So the blue is going to be shifted downward. Okay, so this is going to be shifted downward by 1 unit. Okay, so the last one I'm going to use red. There you go. Okay, so the final picture can be done by shifting. Okay, from what we learned. All right, let's do one more example. This time we have a function. Okay, we have a half. And then we have a x plus 1 squared. Okay, plus 3. Okay, let's see what we get. We're going to start from the same place. Okay, we're going to start from the same place. Okay, so once again, I'm going to use this table. I'm going to start from the same place. So we have that. Okay, and then we're going to do x plus 1 squared. But this picture, because I'm shifting to the left, I need to make a little adjustment. Okay, so maybe this will be -5, maybe this will be 3. Okay, and so there. I'm going to shift to the right. I'm going to shift to the left by 1 unit. So this piece is going to be shift to the left. by 1 unit. So the result of shifting to the left, we're getting x plus 1 squared. Shifting to the left, we're going to use a different color. Let's just use green, right? So that's right. And the next one, we're going to do half. What do you think the half is it going to be? Is it going to be wider than the green or more narrow than the green? That's right. It's going to be wider, right? It's going to be wider. Whoops. Okay, I'm going to add item. And that's going to be, let me just copy this and make it much easier for me to plot it. Okay, so this color, we're going to use blue. Blue. Oh, what's going on here? There. Okay, so this is the blue. Okay, the blue is wider, right? And then +3, look at that, +3. +3 meaning the whole thing plus the whole thing +3. And that's going to be shifting up by 3 units. Okay, so this time I'm going to use red. So that blue is going to be shift up by 3 units. Oh no. Sorry. Okay, I'm just so excited. I thought we were getting almost done. Yeah, I think we need a break, right? So this piece is going to be shifting up by 3 units. So that's the final. Okay, what's going on? Okay, anyway, so this is the second example. Maybe we should do 3-1 because we haven't done flip over, right? We haven't done flip over. So one last example, and then we will take, we reach the end of this lesson. Okay, it's been pretty long. All right, so this example I'm going to give you, okay, f of x, okay. So this time I'm going to have a 3 times, but I'm going to put a -3 in front of it. Is that too big? Let's still do 2 then, -2, okay. This is more modest, right? And x -3 squared, okay, plus 3. Oh, 5 plus 3, 5. Okay. So we're going to start from the same place. We're going to start from the same place. Okay. So I'm going to put my table in place. We're going to start from the same place. Okay. And we're going to do x -3 squared. Whoops. You know what? I made a mistake. Never mind. I need to copy this piece. Yep. Sorry about that. Okay. I think I'm tired. Okay. So we're going to do x -3 squared. Okay. So since this is shifting to the right by 3 units, so I'm going to make just a little bit of adjustment to my picture. Okay. All right. So next is x -3 squared. Okay, so this picture is going to be shifted to the right by 3 units, 3 units. Okay, so I'm going to add x -3 squared. And this is the picture, whoops, not a cubic, not to the power 3. That's going to mess up. The green shift to the right by 3 units. Okay, so I'm going to make it just a little bit wider. Okay, so it sees better, right? And next is a negative. So we're going to do 2 times. Okay, so it's a one more step, 2 times of that. So this picture is going to be, this time it's going to be what? You know what? Before I do this one, okay, we're going to do 2 times. Is it going to be wider or more narrow? That's right. It's going to be more narrow. Okay. So we're going to add that. I'm going to make it blue. There. So the blue. Okay. And next is going to be the flip over. So let me just make sure we get everything documented correctly. Blue. Okay. So here I want to have a little adjustment because we're going to flip over, right? We want to have enough space for that flipping. Okay, we want to have that enough space for that flipping, right? Yes, we want to have enough space for that flipping. Okay, so flip. So next we're going to do negative. Negative. So the blue is going to flip over. The blue is going to flip over. Okay, so we'll put a negative sign in front of it. It's going to flip right over. Okay, now we're going to use purple. Flip over. And one more step, +5. This is the last. Okay, then we're done. +5 will do what? It will shift the entire blue, shift the entire purple picture up or down. Up or down. Up, right? Because it's a +5, right? So the entire purple picture will be shifted up. Okay, so this picture, the final picture, wait. The final picture, no. The final picture will be shifted up. So that's our red. That's going to be our final red. Yep, that's the picture, shifted up by 5 units, by 5 units, okay? In the process, can we identify the vertex? Okay, so now let's look back what we have done. Right, let's look back what we have done. Okay, in the first example, after we shift, right? What is the vertex? The vertex from shifting from 0, 0 to 2, 0. Stay at 2, 0, right? Stay at 2, 0 and shift it down by 1 unit. So what is the vertex at the bottom? So what is the vertex? The vertex in the end is what? What is the vertex? The vertex, right? The lowest point. The vertex is 2, -1. And you can see in this form, it will tell us 2, -1. 2, x minus 2, 2, -1. It tells us the vertex, right? In the second case, we're shifting, right? We're shifting left. We stay here, the vertex here is -1, 0, still -1, 0, and shift. And then of course we make it wider, right? The blue is wider, but it's still at 3, at -1, 0, right? And then we shift it up by 3. So this vertex this vertex is -1, 3, right? -1, 3. So that point. So if you put that point on the graph, right, you put a red dot there. It's right there, red dot. On the previous one, the same thing, right? The vertex was what? 2, -1. Red dot. What is interesting is that from this form, you can tell the vertex, right? X -2 is 2. -1, and this is -1, so that's the vertex. Okay. In the second case, X +1. +1 is what? Okay. X +1 can be written X minus -1. So on your vertex, you have a -1 and the +3, so -1, 3. So you can see this algebraic form will already tell us the vertex. Okay, we're gonna study more of these in the future. And last but not least, we shift to the right by 3 units. We stay here. This is 3, 0, 3, 0. We flipped over, and then we shift up by 5 units. So the vertex is what? What should be the vertex? At 3, 5, right? So the vertex here is at 3, 5. X -3, 3. +5, 5, 3, 5. So you put that 3, 5 in the picture, right? So I'm just gonna copy that point and put a red dot. You see our choices right there. Well, wait. I forgot to select the point, that's why. There, right? So you can see from the algebraic form, you can decide the vertex. X minus something, right? X minus -1 in the case of X +1. And the next case of X -2 is 2, -1, okay? So we recognize these patterns. We recognize these patterns, and in the next lesson, we're gonna continue these discussions, okay? So without further ado, I think this lesson is long enough. Thank you for watching. Until next time.